Hello, Stats class. These are the notes for 4.1b, which is how to sample correctly. We talked about bias on Wednesday, which was the 4.1a, different types of bias, and today we're going to learn how to do it right. So the problem that we're trying to solve is we have biased methods. This is review from 4.1a, which tends to lead us to non-representative samples. And one possible solution, in fact, what statisticians tried to do for years and years, is they tried to just do a really good job of picking the sample. So that's called a judgment sample, where you just do your best to pick a good sample. And we tried that in the warm-up when you were picking states. We didn't try super hard to pick perfect samples, but at least I told you to try to use your best judgment to get a sample of states that represented the states well. And what I'm pretty sure happened, I'm recording this before you do it, but almost every year what happens is people tend to choose the larger states more often. And that is another type of bias that I didn't tell you about yet, called size bias, which means larger things are more likely to be chosen. And that happens no matter how hard you try. I mean, it's just really hard to remember those little itty bitty states. And so the idea is we don't want to throw darts at a map or just pick off of a map or any of those types of methods. Even using your best judgment, there's bias that you might not be aware of coming in. And the solution to that is to make it so that you do not get to choose. Your brain is not allowed to choose the sample. And instead you do random choices, randomly choose your sample, which means you allow chance, some kind of chance device to choose. And often I have people use the word random in the wrong way, so let me just talk about that for a minute. There used to be a club at Cascade called the Random Acts of Kindness Club, which is a great idea. Acts of kindness are wonderful, but it bothered me because they called it random and it wasn't really random. They chose who to give these acts of kindness to, and so that's technically not random, right? If you're just choosing, some people will write for their project proposals and things later on when I make you do a random sample for a project, they'll say, oh, I'm just going to go into the cafeteria and choose some people. Oh gosh, no, that is not random. So random means something else chooses besides you. So for example, you could roll a die. And that would help you choose among 6 people. Obviously, if you have more people, that wouldn't work so well. You could do coin flips. You could walk up to a person and flip a coin, and if it's heads, you ask them the question, and if it's tails, you don't, and move on to the next person. You could spin a spinner. All kinds of things that cause probability to happen without you being in control of it. These ones are not as common because there's not so many options on there. More common would be these ones over here. You could draw names out of a hat. So you could, like if you wanted a sample from our class, you could put names on little pieces of paper, mix them up out of a hat or a bowl or whatever else you want to put them in. You could put a whole bunch of things on little pieces of paper. You could use numbers instead. And that's random as long as you mix well. Right? You could do some kind of technological way. There are things called random number generators, which we'll be talking about. There's a bunch of them online. If you just Google random number generator, you'll find some. So you could use the technological approach, or there's also a thing we're going to learn about today called the random digit table. There are tables out there of random digits that you could use to help you choose your sample without bias. So So these are the three most common ones right here, and the ones that work for just about everything. These are, you'd have to work hard to make it work. Like your spinner would have to have a lot of things on it, but you could make it work if you had to. So what we're going to learn how to do today is the simplest and easiest to explain type of random sample, and then next week we'll learn some other methods that are also useful depending on the situation. So the one that we're going to learn today is called the simple random sample. Also called an SRS. Simple random sample has a few properties that are very good and that we like. So it has the property that every individual in the population is equally likely to be chosen. That sounds fair, doesn't it? And also it has the property where every group is equally likely. So you're just as likely to be chosen with your best friend as to be chosen with your worst enemy. Any of those combinations could work equally well. So every group of, I'm going to say n subjects, because usually our sample size is n subjects, is equally likely. Now that is something we don't always want to be true. So like maybe I might want to make sure that my sample doesn't include all of these people together. And that will be a different type if I was doing that. So for today, we're going to say every possible group is equally likely and every individually is equally likely. And that's the simplest kind. We'll learn the other kinds next week. So we're going to do this a couple different ways. I will teach you the calculator way last. I'm going to start with the table method, which is table D. We already learned about table A, which is the random normal probabilities. There is a B and a C, which I'll tell you about later. Table D, which is in the back of your book. And also I put the handout on Canvas for you. Let's learn how to use it. It is the random digit table. I'm going to just show it to you, and then you can look at it also on your own. It is a table full of what would happen if I took the numbers from 0 to 9, like single digit numbers, and put them in a hat and drew one out at a time. So if I draw one and I write down that it's a 1, and then I put it back and I mix them up again, and I draw another one and it happens to be a 0, write it down. Somebody did that and made this table of digits. Isn't that amazing? Or possibly they used a random number generator with technology. But regardless, these digits are supposed to be randomly ordered, no pattern to them at all. And we can use that. We'll talk about how to use that. So how do you use it? The first thing you do is you have to have a list of your population. Now here's where this method might not work well with a huge population, right? Can you imagine listing every person in the U.S.? Oh gosh. This only works if you have a list. List your population and number it. Number the list. With the states that we were just working with in the warm-up, it's pretty easy to, we already have a list. We could just number them from 1 to 50. And that's called the label step. The book calls it label and table, which is kind of cute. So label step and then the table step. We'll get that in a sec. When you're using the table, you need to make sure you use the same number of digits for everybody. So in other words, those 1-digit numbers, 1 through 9, I would number them as 01 through 09, and then all the way up to 50, not 1 to 50, because on the table, we're going to be looking at 2 digits at a time. And so 1 doesn't represent a 1, it represents a tens digit. And yeah, just use 2-digit numbers or 3 digits or whatever you need when you're doing your numbering. Okay, so then you're going to use a row of the table. Usually people choose a random row of the table, and I'll tell you how to do that. Any row will do because they're random, right? And you read groups of however many digits you need. In this case, with the states, we'll be using 2 digits at a time. If n is 10 or fewer, then you can just use single digits, and that works fine. If n is between 10 and 100, then Actually, if n equals 10, you could still use single digits because you could make 0 represent 10. So I should make this be a less than without the equal and make this be a less than with the equal. Because if it's 100, you could go 0 to 99, or technically 0, 0 to 99. But that would be 2 digits at a time. And so on. If you're between 100 and 999 or 1,000, you would use 3 digits, and so forth. So you decide how many digits you need based on how big your population is. If you happen to get a duplicate, you have to throw it out. And you also throw out extra numbers. So like when I'm still using the states as an example because we're about to go back and finish that activity. But the extra numbers, if I'm numbering my states 0, 1 through 50, that means if I get a 51 or a 79 or something else that's not between 1 and 50, I would need to decide what to do with that. So in this case, I would throw out those numbers that are greater than 50. I just would ignore them and move on. So I'm going to do an example using the table, and then you're going to do it yourself by finishing up the Desmos. So I'm going to use row 43 because that's the one I used last year. I don't really have a good reason for it, but just to demonstrate that it could be any row. So I'm going to use row 43, and I'm going to write down the first part of row 43 since it's really hard to read on my screen right now. It is 80951. And I'll demonstrate how to translate this into the states that you need. And 00406 and 96382. And if I need more, I'll do one more just in case. Okay, so there's the first part of row 43. So what I'm going to do is I'm going to go down the row and take 2 digits at a time. They're in groups of 5 to make them easier to read, but I'm just going to ignore those spaces and go these 2, 80, 95, 10. I'm just going to go down and split them into groups of 2. And you can write on your table if you print it out, and that's fine. Or you can write down the numbers like I did. I'm going to go down the row and decide what state they are. 80 and 95 are both too big. I'm throwing them out. That's fine. 10. I can do 10. So I look at my list of states, and I see that 10 is Georgia. Okay. 4 is the next state on my list, and so that's Arkansas. I think that's AK or AR, I'm not sure. 6 is Colorado. 96, I have to throw that out because it's too big. 38, I'm going to keep going until I have a sample of 5 states like we did in the warm-up. 38 is Pennsylvania. 27 is Nebraska. And now I have 5, and so I wouldn't need to do the 7. And also, if I had happened to get a repeat in here, if I got another 10 or another 4, I would throw it out and move on. So that gives me my 5 states that are in my sample, and then I look up their areas and average them. And this is the same thing that you did in the warm-up to get your 5 states. So except you chose them. This time you're not choosing them. So I would take my Georgia is 59425. I'm just reading these off the chart. Arkansas is 53179 and Colorado. So basically I'm just looking them all up. Maybe I won't do all of them because you kind of probably get the point already. And divide by 5 and get my average. Okay? You're going to do that when you go back to the Desmos, and you're going to do it with a random sample. I'm going to ask you, actually it says this in the Desmos also, but I'm going to ask you to take the last 2 digits of your phone number because I want everybody to have a different row if possible, or close. And then if your phone number has the last 2 digits more than 50, you're going to subtract 50 from it. And then you're going to use that row of the table. So my classroom phone number, for instance, ends in 58. And I would take my 58 divided, or minus 50 is 8. And I would use row 8 of the table for this activity. And those are the numbers that would give me my random sample of states. Maybe I should have done that before I started doing row 43, but that's okay. So this is, you're going to finish the Desmos after you finish this last bit of notes. But before you get there, I'm going to do one more thing in the notes, and that is to tell you how to do the calculator method, because sometimes that's better than the table. Some people like it better. And there's a lot of online random number generators also, but I want to show you how to use your calculator as a random number generator. It's in the math menu and then probability. Put the light on so you can see it. Math and probability is over to the side. Choose that. Wait, that's not what I meant. I don't want just plain rand. I want rand int. Rand int. And then I have to tell it between what and what. So rand int, I have to give it my low number and my high number and how many I want. So in this case, you could do this on the for the activity if you'd rather, but low number would be 0. No, actually 1, because I'm not going 0 to 50, I'm going 1 to 50. High number would be 50, and then I want 5 of them at a time. The only disadvantage of this is that sometimes it gives you duplicates. This one didn't. 12, 19, 1, 47, 6 happens to be a set of states that I could use. If I hit it again, one of these times I'm going to end up with a duplicate, and I would just throw that out. So that's a quick way to do it. Go from 1 to 50 and 5 at a time. Still need to throw out duplicates. Or on the newer calculators, the TI-84 Plus has this, and some of the TI-84s without a plus have it. Math probability. Way down at the bottom, there's a thing called rand int no rep, which is basically no repeats. So you could do 1, 50. I don't think it'll let you enter the comma 5. I'm testing that just to see. Nope, it doesn't like the extra 5, so delete that. And if you do that, it gives you all 50 numbers in random order, and you just use the first 5. So there's another option that some of you will be able to do and some won't. No rep, 1, 50, then use the first 5. All right, so that is it for the notes. You're going to try this by going back to the Desmos activity, and I do this in class also. We do the warm-up, and then we do the notes, and then I say, okay, now we're going to finish the activity. So I'm making you do the same thing. So please go back and finish the Desmos, and I've unlocked it now so that you can see all the rest of the screens, and you will do a random sample that is not biased, and we'll see if that does better. And that is it for today. Thanks. Bye.